Now we are going to start with the detailed study of potassium permagnate and potassium dichromate. These are actually two important compounds possessing many important properties. So first of all, we'll look for the chemical formula. So potassium permagnate is actually, you know, that KMnO4. It is KMnO4, and potassium dichromate is K2Cr2O7. So these are the molecular formulas for them. So potassium permagnate is KMnO4 and potassium dichromate is K2Cr2O7. So how they are obtained? Actually, this is obtained from a pyrolusite ore, right, which is generally MnO2, and it is obtained from ore that is the chromite ore. It is obtained from an ore called as chromite ore, which is FeCrO4, which is FeCrO4. We get we can obtain from chromite ore. So now starting with the preparation first, that how they are prepared. So potassium permagnate is prepared, in which what we do is we take a pyrolusite ore, that is MnO2, we react with KOH and a nascent oxygen. Right. We can also use, instead of KOH, we can also use potassium carbonate. It will also yield the same result. So what happened? We get K2MnO4, potassium magnate, with this thing we get, this is K2MnO4 plus we get H2O. Then in the second step, what we do is we react with this K2MnO4 with carbon dioxide, and as a result what do we get? We get potassium permagnate with K2CO3, and along with that we get MnO2. This actually stays behind, it is insoluble, so it settles at bottom. So if we talk about the color, so K2MnO4 is actually green in color, and this is brown in color, and KMnO4 is purple in color. So what we do after that, we just filter it, and when we filter it, MnO2 is removed. So this is actually removed as a result of filtering, and after that we need to concentrate the solution, and what happened? We see that KMnO4 crystallizes out. KMnO4 crystallizes out. So this is how you are going to prepare KMnO4. Now if we talk for the preparation of potassium dichromate, we prepare it by chromite ore, that is FeCrO4. So how we are going to prepare it? In the first step, I am going to react this with this thing Na2CO3. So and what do I get? I get Na2Cr O4, I get this sodium chromate, and along with that we get Fe2O3 and oxygen is removed. Only a small little amount of oxygen we get, CO2 we get. Then in the second step we try to convert the sodium chromate into sodium dichromate. What we do, we react it with sulfuric acid, and when we react it with sulfuric acid we get Na2SO4, we get sodium dichromate Na2Cr2O7, and with that we get water. Then in the third step we react sodium dichromate with KCl, because we need to prepare potassium dichromate actually, and here we get K2Cr2O7 with NaCl. So this is our desired product, that is the potassium dichromate. So how we obtain? We reacted with chromite ore with the sodium carbonate first, and then this sodium chromate is reacted with sulfuric acid, and then the sodium dichromate is reacted with KCl, and we get this kind of product. And you know that when we are heating it, we need to heat it, and we add a little amount of lime also, because it keeps the chromite ore porous, so that a better reaction can take place actually, and it is heated on a hearth, and here it is heated on in a furnace. So this is how we can prepare potassium dichromate, and here we can prepare potassium magnate. Now if we look for them, that how they look like actually, so we will see that it is actually a it is actually a kind of purple crystals. It is purple in color. And if we look for it, like how it looked like orange red in color. It is actually orangish or red, orangish red you can say in color. Now you know that if we just expose it to sunlight, it gets decomposed. When exposed to sunlight, it get affected, therefore it is stored in dark bottles. We need to keep it away from the sunlight because it gets, otherwise it gets decomposed. So we need to keep it in dark bottles. And you know that when we add excess water to it, it turns into a pink color solution. Obviously purple when added and when water is added, so obviously the purple color will fade away and it will turn into a pink color solution. So excess water makes the potassium permanganate pink color solution. Now if we talk about the action of heat, the first property I am taking into consideration is action of heat. That what happens when I heat this. Suppose I have KMnO4, I am going to heat it. When I am going to heat it, it gets decomposed and it will compose into a K2MnO4, that is potassium magnate, and with that we will get Mn2O3 and this thing, little amount of oxygen is removed. And you know that when we heat potassium dichromate, then what happens? When we heat potassium dichromate, it gets break up into potassium chromate, along with that we get chromic oxide and oxygen gas. So that means they get decomposed on heating, turns from dichromate into chromate. Now what is the effect when we react with alkali? Suppose I have KMnO4, I am going to react it with alkali, let us take caustic potash, that is KOH, then it will get converted again into potassium magnate, and along with that we will get this thing, it will get water. And here when we react with alkali, then also we will get the same thing, that K2Cr2O7 when react with alkali, it will again form K2CrO4 and along with that we will get a water. So this is how it is going to react with alkali. The third, we are going to react with an acid. Let us take a sulfuric acid, because we know that sulfuric acid is a king of chemical, right. So we take a sulfuric acid. We see that when we react with sulfuric acid, what do we get actually? We get again this thing K2MnO4, along with that we get Mn2O7 and water. You know that this Mn2O7 is so explosive in nature that when it comes in contact with air, it just causes an explosion, it just explodes, this Mn2O7, because it's highly unstable. Now if we react this with acid, we will see that when we react them with acid, sulfuric acid, actually it shows two kind of reaction, when we react it with concentrated sulfuric acid and when we react with dilute sulfuric acid. So let us say concentrated this side and dilute this side. So what we see that when we react with dilute, we get K2SO4, we get Cr2SO4 whole thrice, we get this water. Right, and here when we react with concentrated, we get CrO3, we get KHSO4 and along with that we get a water. So that means it shows a different kind of reaction when we react it with dilute sulfuric acid and when we react it with concentrated sulfuric acid. And you know that potassium dichromate shows a popular reaction, it actually can give the chromyl chloride test. It actually can give the chromyl chloride test. And what is this test basically? It is the test used for the detection of chloride ions. How you are going to do it? We take potassium dichromate, we react with NaCl followed by H2SO4. So what do we get here? We get KHSO4, we get sodium bisulfate, potassium bisulfate, sodium bisulfate. Along with that we get an orangish reddish color compound CrO2Cl2 along with water. So this formation of this compound, that is orange reddish color fumes, if you can see that they are coming out. So this actually confirms that yes, the chloride ions are present in the given substance. So this is actually a test to detect the chloride ions. So it can undergo a chromyl chloride test also. So now if we talk about the main property, you know that both of them actually act as an oxidizing agent. Both of them are powerful oxidizing agent. They are powerful oxidizing agent, both of them. And now in which medium they oxidize, we get the we get different products depending upon the medium which they use to oxidize a substance, that whether the given medium is acidic, neutral or alkaline, a different kind of products are formed. So just we'll focus on that. I'll just clean it, then we'll focus on the oxidizing agent property, because I'm going to show you many reactions on it. So just look at the board carefully.